So, factoring is reverse of multiplication. It kind of is division, which is what we would say is the inverse of multiplication. But now we're looking to do it with many terms at a time. So what does it say? To factor out polynomials to find an equivalent expression that is the product of polynomials. An equivalent expression of this type is called the factorization of the polynomial. That sounds nerdy. I'm not going to talk about it anymore. But the greatest common factor, this is the first thing you should always look at when it says to factor. Because if you can, you should. Which will make usually the other types of factoring that we have much easier. So if you can take something out from each of the terms, set it aside, and then look back at what's left over. So we'll look for any greatest common factors. Of course, the first couple problems here are just focused on greatest common factors. But then after that, we'll look at the other strategy for today, factoring by grouping. So to factor it out, place the non-common factors in a set of parentheses and multiply the parentheses by the greatest common factor. But it has to be the greatest common factor for all the terms. If it's a binomial, it's got to be with the two terms. If it's trinomial, 3, and then so forth. So I like to look at just the numbers first, because usually it's going to have numbers and it's going to have letters. If it has more than one letter in the polynomial, I will look at different letters separately, because I can't factor out x's like I would y's. With y's, I should say. We've seen this before, where we say, look, you can distribute the 4 into the set of parentheses, and you can feel good about it, right? Because you could get 4x plus 12 from the multiplication, which is distribution. Now, though, what we're doing is, from something like this, I say, look, I can pull out a 5 from the 5x and the 30, but what's left over? Well, from the 5x, you'd have an x left over, and what's left over from the 30 is the 6, because really all we're doing is dividing, which is the factoring part here. So, yeah, we're just trying to find values from all the terms that we can yank out, which then becomes, in this case, right, that 5 is our greatest common factor between 5x and 30. Just like this one, if you had started with 4x plus 12, you can yank out a 4 from both of these terms and get this original expression, if you wanted to go backwards for some reason. So this one looks, it looks pretty nasty. There's some, yeah, right, there's like some big numbers in this stuff. Don't worry about the other stuff right now. Like I said, focus on one part at a time, see what you can yank out, and then that's what we will do. So let's see if this will, it's not giving me the right, let's try this. There we go. Now, why am I putting this in parentheses? Because like I said, I'm going to find common factors from all the terms and yank them out, okay? So whatever I get out of these, something's going to come out, and then whatever's left stays inside. So first, let's just focus on the numbers. I've got 20, 22, and negative 28. I will say this, usually if this first term is a negative, we'll factor out a negative no matter what. All that does is change the other signs. This one's not, so we don't have to worry about it. Now I look at these three numbers. I got 20, 22, and 28. In 990, maybe, definitely 920 though, we say, find the prime factorization of these. I'm not going to do that, but you could, yeah. So what I would recommend doing is going through your multiplication, your divisibility rules and seeing what you can divide by. Usually you're not going to get something funky like 17, right? Like this one, we say, look, you got 20, 22, and 28. I really don't care about the negative, but I have a number ending in 0, 2, and 8. They're all even at least. At least I should be able to factor out a 2, right? So what happens when I do that? And I'm going to check even after I factor this out. So I'm going to say, I'm going to factor out a 2. That means I'm dividing these each by 2. So I'd say 20 divided by 2, boom, is 10. 22 divided by the 2, that factored out, right? That's the 11, positive. And then the 28 divided by 2 is negative 14. Okay, now that's just the numerical part of it, okay? Now that I factored out a 2, which is kind of small, I would go back and check through these 10, 11, and 14. Like 10 and 14, you could factor out a 2, but 11 can't. That cancels out all factoring from here on, so for the numbers. So the numbers are done. Now that the numbers are done, then I want to focus on just letters. I'm going to do this below because I probably should have given myself more space, but for the first term, I have a squared. For the next term, I have a cubed. And for the next one, I have a to the power of 9, which kind of looks like an a. But for all three of these terms, is there a certain number of a's that I can yank out from each of them? Yeah, 2 is the most because this one only has 2. So automatically, oh crap, I'm gonna need more space with that. 2, my bad. So let's set that 2 aside. But yeah, we can factor out an a squared from these, okay? So from this a squared, I used up all of them, so that one goes away. That's the first term. The second term, I just took away 2 of those, and so I'm just left with a. You can show the power of 1 if that makes you feel good inside. And then the last one, that's 9 minus 2, right? I took away 2 of them, so that's a to the power of 7 now. All right, so that's my a's. Let's look at the b's then. So the first term has b to the power of 6. Next one is b to the power of 8. And then just an individual b. I think you guys are noticing the pattern even now, but this b right here, like we got 6 and 8 of these ones, that's a lot. This one only has 1, so as it turns out, I can only yank out 1 from each. I'm gonna do it with each of them, right? So the first term, I just took out a b right there, so that's now b to the power of 5. The second one is 8 minus 1, so that's b to the power of 7. And then this b right here, we took out all the b's from this last term. Next up, we have c. Yeah, so that first term has c to the power of 5. That last one has c to the power of 7. You'll notice there's no c's. That's not, maybe x isn't the right thing to do there. But there's no c variables in the middle term. This means that we can't factor out. Some students are like, well, I can take out 5 c's, right? No, there's nothing you can do with that middle one. It has to be with all of them. Okay, so this, those c's, I need to put them in there, though. So c to the power of 5. And then c to the power of 7. So yeah, this is, so the last thing we'll do here is we would check for any other forms of factoring, but I forget we haven't gone over them, so that's it.